Hi everybody. In this lesson we want to look at some rational exponents. Now remember in math whenever you hear rational you should think ratio, and a ratio is a fraction. So this is about fractional exponents. So if I were to look at say the 27 squared and then take the cube root of that, we can use that using rational exponents as 27 squared. And remember that a cube root is the same thing as raising it to the 1/3 power. So the 1/3 power is the same as the third root. And then by my rules of exponents, if I multiply those exponents, I'd get 27 to the 2/3 power. Okay, so now we can talk about fractional exponents where you can have any numerator instead of just one that we looked at before. Okay, so notice also that 27 to the 2/3 can also be evaluated one of two ways. You can either write this as 27 squared to the 1/3 power like I did up here, but then I have to know what 27 squared is, so I'd probably have to pull out my calculator for that. And so I'd have to figure out 27 squared is 729. That's a big number. And then I'd have to figure out what the cube root of that is. And again, I would have to use my calculator for that. I could raise that to the 1/3 power or use my cube root button. And I get 9. Okay? Now as I mentioned, that's the hard way. A much easier way is to recognize that I can also write this as 27 to the 1/3 power and then square that, because I'm still going to multiply 2 times a third to get 2/3. But this is a lot easier because I can take the cube root of 27. Remember, the 1/3 power means the cube root. So that would be 3. And then I can square the 3, and I end up with the same 9. So the moral of that story is that whenever you're doing fractional exponents, notice that the denominator is a root. So you're going to take the root, and then the numerator is the power. And you always want to take the root first because it'll make the number smaller and much easier to compute without a calculator. So 25 to the 3/2 power, I'm going to think of that as 25 to the 1/2, which is the square root of 25, and then cube that, and 5 cubed would be 125. 125 to the 2/3. I'm going to think of this denominator, that's the root, so that's the cube root of 125, which is 5. And then I'll square that 5, and that will give me 25. Okay? 16 to the 3/4 power. That's the 4th root of 16. And then I'll cube that. So the 4th root of 16 is 2, because 2 times 2 times 2 times 2 is 16. So 2 is the 4th root of 16, and then I want to cube that. So that'll give me my answer, which is 8. Now on these, you don't necessarily have to write out as I've done here. I've done this to help you to visualize what's going on, but eventually you'll want to come to the place where you can say, oh, the 4th root of 16 is 2, and 2 cubed is 8, and you could just write the answer down. Or the cube root of 125 is 5, and 5 squared is 25. Or over here, the square root of 25 is 5, and 5 cubed is 125. So in this case, 8 to the 2/3, I'll take the cube root of 8, which is 2, and then I'll square it. Okay, so that answer is going to be 4. And if I wanted the negative of that, now you'll notice here I've got a bunch of problems down here all in a row. 8 to the 2/3, negative 8 to the 2/3, and I have negative 8 in parentheses to the 2/3. And then down here I've got 8 to the negative 2/3, negative 8 to the negative 2/3, and then this quantity negative 8 to the negative 2/3. So these are 6 examples to help you see how the fractional exponents work, also with the negatives. Now this negative right here, this is the additive inverse. This is the opposite of this number right here. So this is just going to be a negative 4. This just means the opposite of the number we got over here. Now what's different about this one is the base is negative 8. So this here would be negative 8. And I'm taking the cube root of negative 8, right, which is going to be negative 2, and then squaring that. So the cube root of negative 8 is negative 2, and negative 2 squared is positive 4. So you'll notice that when I had the negative without the parentheses, I got a negative 4 because this is the opposite of a positive number. Here, I had a negative number raised to a power, the 2/3 power. So I take the cube root of negative 8, which is negative 2, and then I square that negative and it becomes positive. The difference is the base. Here the base is negative 8. Here the base is 8, and then I'm putting a minus sign on it. Okay, let's move down to this next set of problems. 8 to the negative 2/3. This negative is not like this negative. This is the additive inverse. This is a number smaller than 0. This is the multiplicative inverse, right? This means the reciprocal. This is 1 over 8 to the 2/3. So that's going to be 1 over, and again I take the cube root of 8 is 2, and 2 squared is 4. So this is 1/4. Notice that 8 to the positive 2/3 was 4. Cube root of 8 is 2. 2 squared is 4. 8 to the negative 2/3, that's the reciprocal. So this negative is the reciprocal of the one we got up here, 1/4. Now this is a negative 8 to the negative 2/3. This is the opposite of what I just did over here, right? So this is just going to be a negative 1/4. And here, what's different is the base is negative. So this would be, and these two negatives are different. They're not going to cancel each other out. I'm going to have 1 over a negative 8 to the 2/3. So this negative here is the reciprocal, and then this negative right here is inside the base. So we did this up here. Negative 8 to the 2/3 is 4, so this is all going to be 4. So this is going to be 1 over, I'll do it in slow motion again, negative 8 to the 1/3, which is negative 2, and then I have to square that. Alright, so this is 1 over negative 2 squared. All of this is negative 2. The cube root of negative 8 is negative 2. Then I have to square it, 1/4. Okay? Alright, let's do another set of problems like that. This previous example, notice the denominator was odd. Here the denominator of the fraction is even. So this is going to be the square root of 9, right? 9 to the 1/2, and then cube. So 3 cubed is 27. Here is the opposite of what we just did here. So this is going to be a negative 27. Now here the base is negative 9, and I'm taking the square root of a negative 9. I can't do that, right? So this would be negative 9 to the 1/2 power cubed, which is really the square root of negative 9 cubed. And so this is going to be not a real number. So I can't take the square root, I can't have an even denominator of a negative base there. Alright, now this negative here, remember, this is the multiplicative reciprocal, the multiplicative inverse, which is the reciprocal. So this will be 1 over 9 to the positive 3/2, and we just did 9 to the 3/2, right? The square root of 9 is 3, and 3 cubed is 27. So this ends up being 1/27. This negative out here these two aren't going to cancel. This is the additive inverse. This is a negative number. This is the multiplicative inverse. So this is just the opposite of what we got over here. That's a negative 1/27. Okay? And likewise here, this would be 1 over, to get rid of this negative, it would be 1 over negative 9 to the positive 3/2. But I'm back to trying to take the square root of a negative number. So that's going to be not a real number. Okay?